All right, number 9. So we're still doing our bottoms up with trinomials, and the leading term is not just x. So I have 8 times 9 is 72. And we want to find the factors of 72 that subtract, because this is a minus, to get a -1. So I want to subtract to get a -1 because there's an understood 1 in front of that x, and since it's a minus, it's -1. All right? Now, 72 is kind of a big number. It's not really that large, but I want you to see the last two examples. Number 8 and number 9. When I multiplied the 8 and the 9, I got 72. 8 and 9 are factors of 72 because anytime you multiply two things together, that's what is considered a factor. Look at number 8. 5 and 2 are factors of 10. Notice that those are the two numbers that I used to get my factored form. So anytime you have a big number and you have a number in front of your x squared, see if those two numbers that you multiplied can be the factors that I can subtract to get my middle term, or add or to get your middle term. So 8 and 9, I can subtract them to get a 1. So 8 times 9 are going to be my factors of 72. This is just a kind of a shortcut way of finding your factors, is always looking at these two. It don't always work. Like on number 7, we didn't use 4 and 3. So just check first if they're big numbers, if you're having a difficult time. And sometimes they do work, like on number 8 and 9. All right, so when we're subtracting, remember they're going to be different signs. The bigger number is going to be the sign of that middle term. So that means our 9 is going to be negative, and our 8 is going to be positive because they have to be different signs when you subtract. Now when I divide by the leading term is 8x. Divide by 8x. And now we're going to see if we can reduce. On the first fraction, I have 8 over 8. I can reduce 8. We'll go into 8 one time. 8 will go into 8 one time. And when I bottoms up, I have x plus 1. Okay? 9 over 8 will not reduce. So when I bottoms up, I have 8x minus 9. Bottom to top. Bottom to top. Okay? So that's number 9. I'm going to scoot it up and we'll do number 10 on the next page. Alright, so still going to be working with trinomials, and we have, I think, 4 more examples, and that's it. 5 more. Alright, so we have 14, 4, and 10. If I multiply 14 and 10, I have 140. That's kind of a big number. So remember what I said about if you did multiply and you get a big number, what is a thing that you can think of to make your number smaller? The GCF. Well, 14, 4, and 10 are all even, so I know 2 will go into all of them. 4 is your smallest number. 4 won't go into all of these. So your GCF will have to be 2. And we don't have a GCF for our variables, so 2 is going to be our GCF. So I'm going to say 2 into 14 is 7. Bring down your x squared. 2 into 4 is 2. Bring down your x. 2 into 10 is 5. So remember, you want to bring your GCF down and scratch it out so you don't get preoccupied with that on the outside of your parentheses. So I went ahead and I brought my GCF down in my final answer. And now I'm going to do my bottoms up. So 7 times 5 is 35. And I want to find the factors of 35 that subtract to give me a positive 2. So I want to subtract to get a positive 2. So remember the trick that I just showed you, the numbers on the outside, the 8 and the 9? Let's see if they'll work for the 7 and the 5. So can I subtract 7 and 5 to get 2? Yes. So that means these are going to be my factors. 7 and 5 will subtract to give me 2. So these are our factors for our problem. And when I subtract, I have to have different signs. The bigger number is going to be positive. The smaller number is going to be negative. That's a really hard negative to see, so I'm going to put it in red so y'all can see it. All right, so I'm going to divide by my leading term, and my leading term is 7x. And we want to reduce if necessary. So when we reduce, 7 will go into 7 one time, 7 will go into 7 one time. So I have x plus 1 as my first factor. 5 over 7 will not reduce, so I have 7x minus 5. And this is in factored form. All right, now 11 looks tricky. 11, it just looks like there's a lot going on in number 11. So let's look at it. We have an x squared, we have an xy, we have a y squared, we have a 6, an 11, and a 10. There is not a GCF in this entire trinomial. And the reason why there's no GCF is because, remember, GCF means common factor. It has to be common to all. I have an x in the first and the second, but not in the third. I have a y in the third and the second, but not the first. 6 won't go into 11 or 10, and 11's not even. So there's nothing that I can take out. So what's going to actually happen is, don't even worry about those y's, and just factor it with bottoms up like you would normally do. So I have 6 times 10. This is going to give me 60. So I want to find the factors of 60 that subtract to give me a negative 11. All right? And I'm going to use that rule of 6 and 10. I can't subtract them to get 11, so it's not going to be an easy one. So let's go ahead and look at our factors of 60. I have 1 and 60, 2 and 30, 3 and 20. I can't get 11 with any of those. 4, let's see if 4 will go into it. 4 into 60, 4 will go into 6 one time. Yes. So 4 will go into 60, and I'm dividing over here. So I had 4 into 6 will go one time. When I brought my 2 down, brought my 0 down, 4 will go into 25 times. So 4 times 15 is 60. And when I subtract 4 and 15, I get 11. So these are our two factors. And I am going to divide by my leading term, 6x. I forgot to put my signs on them, so let's do that before we go any further. Remember, when you subtract, you have to have different signs. This has to be the sign of the bigger number, so that means my 15 needs to be negative. My 4 needs to be positive. So we divided by our 6x already. And let's reduce if we can. So 4 and 6. 2 will go into both of those. So 2 will go into 6 3 times. 2 will go into 4 2 times. So for this one, 15 and 6, I can reduce this one too. 3 will go into both of those. 3 will go into 6 2 times. 3 will go into 15 5 times. So the difference between this problem and the problem we've had in the beginning, I told you to just ignore the y's, is when you put it in factored form, you're going to have an x in the front, a y in the back. An x in the front and a y in the back. This is just what your factored form is going to look like. So put your numbers that you just factored and found into that factored problem in that form. So I'm going to have 3x plus 2y. So 3x plus 2y for my first factor, and 2x minus 5y. And that's in factored form. So the only difference is you're going to have y's in the back of your factored form. All right, I know this video ran long, so I'm going to pick up on the next one in number 12.